All right, just for the record, we're going to be doing quadratics. Just in case someone doesn't remember the quadratic formula, there it is. Okay? You can sing the song if you want to later. Okay? Quadratic formula, I think, is the overkill for this. Okay? So, typically how I think about this problem is I multiply 2 times 2 together. I get 4. So that means that I have to get, what factors of 4 add up to get 3? You can think about it that way. However, guess and check for this kind of problem works really, really well. 2 breaks down into 2 times 1. That's it. So you're going to be working with 2 and 1s or 1s and 2s. So pick one way and plug it in and check it. And here's how I would check it. Now, the next part I'm writing on the screen actually happens in your head most of the time. And so when you look at it, you can check it out. Too fast. You can check it out and go like this. If you do the FOIL parts, the first part, 2x times x, that is not 4x squared. So you have 2. Okay, so 2x squared here. The next one, if you do your outer terms, that's 2x times 2, give you 4x. And the next one would be 1 times x to give you x. And the last one would be 1 times 2. The tricky part is getting your signs to work. Remember, most of this right here is going to be going on in your head. This is just kind of a way of making sure I'm getting it right. How can I make a 4 and a 1 become negative 3?
Negative 4 plus 1.
Yeah, I need it to be negative 4 plus 1. So here, negative 4 and a positive 1. How can I get negative 4? The outer terms need to be negative. So 2 times negative 2 gives you negative 4. 1 times x is still x. And so when you look at it, to solve the equations, we set each part equal to 0. And you solve. And so you end up with this kind of problem. Questions about that? In this scenario, when you have a quadratic to start with, they will always work. What are the 2 problems we have to check our answers on? Like, sometimes we don't, one of the answers is extraneous, it doesn't work. There's only 2 problems I have to worry about that on. This one I don't have to worry about it. Square roots, if my original problem was a square root or fraction. Like x is in the denominator. Otherwise, I don't have to check them. Questions about that? Okay. Let's go on and try the next one. I will tell you this. Don't solve this one the same way you did the last one. Because you have a perfect square equal to a perfect square, that's red light saying square root both sides. But there's one careless mistake that always happens. What's the square root of 9? Plus or minus 3. Here's how you can check your answer. Or you can check yourself. What's the degree of a quadratic? What's the degree? What's the largest exponent in a quadratic?
What's the what?
The degree.
2.
It's 2. How many answers should I have when I solve a quadratic?
2.
2. If you leave off plus or minus, you'll end up with 1 answer. That's kind of another red light saying you did something wrong. You left something out. So you should get 2 answers. Take the square root of both sides. Then you separate them into 2 little cases and work them out. One with the positive 3, one with the negative 3. And you just work it to the end to your solution. Any questions about that? Okay, let's try another one. Since completing the square is easy, some of you said, Okay, so we're going to do this one. Shh. This is about as hard as completing the square gets. There's two things that can make completing the square difficult. Number one, when you have a number that's not 1 out front, that causes a problem. Number two, once I get into the problem, when I have to do the b over 2 part, if that b is odd, I'm going to end up with fractions in my equation.
Oh, yeah.
And both of those things happen here. So I'm not going to let you worry it out because I don't know that you remember how to do this. This is actually my least favorite part because there's so many pieces to it. It's not that difficult once you know the procedure. All right, but the key to doing this is this. If you forget b over 2 squared, not going to happen. I want you to do this way just to practice. You could. Now, on an assessment, generally, I'm probably not going to ask you to do it a specific way. Okay? But certain times we have to know how to complete the square. So I want to just go through the process, remind you what it is. The first thing we have to do, there are going to be like 4 steps to this. The first thing we have to do is we have to get organized. So I'm going to organize it so that my x's are on one side of the equation and the constant value is on the other side. Okay? So we're going to go ahead and rewrite this. And I leave a little bit of space in between the 20 and the equal sign, because we're going to put something there in a minute. Step number 2. Before I can complete the square, the coefficient of x squared has to be 1. Otherwise, I won't know what my b is. B is, technically, in this equation, my b is negative 20. But that's not the one I'm going to be using in completing the square. So here's what we're going to do. We're going to factor out the 4 and rewrite it. You leave the negative 17 just like it is. This also makes my number smaller, so I don't have to worry about a 20, halving that, squaring that, and then adding it all over. But at this point, I'm going to complete the square. So at this point, we have our b is negative 5. So we're going to use this part, and we're going to fill in the space. So what is b over 2 squared going to equal to? B is negative 5. The b we use is the b that's inside here, not the one here. So here's the second problem. When I take half of 5, that's a decimal or a fraction. Leave it. In this case, it doesn't matter. I'll leave mine as a fraction because fractions are much easier to square than decimals. A lot of times you won't have a calculator to do this. So we're going to take b over 2 squared and we're going to put it in place. Sometimes. Oh, there's going to be entire chapters where I'm going to tell you not to use a calculator at all. In fact, I'll tell you, you can bring it with you all day and you can have it on your desk. You know, if you need to, if you need it for your security blanket or your passy, then you can keep it there and it's totally useless because we won't be using any numbers.
Really? No numbers in that?
That's probably bad. Yeah, we'll get there. So what's 5 over 2 squared? 25 fourths. Shh. My point is this. Calculators are useful, definitely. But there are times where the calculator where you think it helps you more actually causes more problems than it does solutions. Well, if I square 5 over 2 as a fraction, it's 5 squared, that's 25, and 2 squared is 20, that's 4. But if you do 2.5 squared, what's that?
Some kind of last number.
What's 2.5 squared? I mean, you could do it. 2.5 times 2.5. Yeah, 6.25. But you wouldn't have thought that in your head. I can square a fraction in seconds, where I may have to think about squaring a decimal point. It's like multiplying with big numbers. So fractions aren't always a bad thing. Anyway, look on the screen. Shh. You're going to take that 25 fourths, and that's what goes in the blank right here. What do we do next? Who remembers?
Distribute that 4 back in.
I have to distribute the 4 to the 25/4. That's actually nice because it makes it a lot nicer number to work with before I add it to this side. Right? So 25, what's 25/4 times 4? I heard the right answer. 25/4 times 4. The 4's cancel. It's 25.
Oh, cancel?
Yeah? 4 on the bottom, 4 over 1 on the top.
Oh, yeah.
So the 4's cancel out, you're left with 25. So I'll add 25 to this side. And here's the part. You're done. That's the hard part. If you get there, the hard part's done. The next couple of steps, there's almost little to no thought that you have to do. You have to remember where you what you put together. Okay? So mathematically, here's what I want you to do. I want you to factor this nasty thing right here, and then I want you to add these two numbers together. However, the trick is that I don't actually have to think about it to factor it. I chose how to make that because we used this, right? So here's what's going to happen. My variable is x. Okay? I need to know what number I squared, and that's it. So here's what we're going to do. We're going to make sure to remember that. I'm going to bring that 4 down because it's outside of it, so the 4 stays outside. So whatever number you have outside, just bring it down. The next part, my x is my variable. What did we square to get 25/4?
Negative 5.
Negative 5 over 2, right? Write that down next. Yes, sir.
You subtracted 25. Wow.
No, because negative times negative is positive. Okay? Shh. See this right here? The number that goes right here is the number that you squared. Since I squared negative 5 halves, I put it right there, negative 5 halves. And then I write a square above it. And then you've simplified the other side to get 8. Questions? What we really did, listen, what we really did was we went up here and I factored this whole thing. And it becomes this. But I didn't really factor it like we normally factor things. The whole point of this exercise is to create that, but you did it on purpose. So if you want to factor this, what times what is 25/4? Oh, 5 halves, right? Well, what plus what is 5? What's 5 halves as a decimal? What's 2.5 plus 2.5? 5. So if you were to write this out in x minus 5 halves times x minus 5 halves, that would equal this thing. Anyway, 25 minus 17 gives you 8. How would you finish this problem? At that point, you're done completing the square. And we'll stop here. I divide by 4. And then what? Then take the square root and finish it out that way. Okay? All right, listen carefully. Most of the time, I'm not going to ask you to do this. I wanted to review it because this is one of the ones that is not very nice to work with. Okay? There are certain things that I have to complete the square to do. Okay? To graph a parabola from another form, I have to do this. If you guys remember conic sections, the ellipse, the hyperbola, all that stuff, you had to complete the square in order to get it in the right form. There are certain times, and we're not going to do that this year, there are certain times that you need this. But I'm not, in this chapter, I'm not going to ask you to do that.
We do proofs.
No. Although we're doing something similar to proofs.
Oh, yeah.
That's the bad part.
That's so fun.
I know, it's exciting. Okay, change gears for a second. This is simple. Can you factor that for me, please? Real simple. Take 60 seconds and factor it. To factor this one, we take the numbers that multiply to get 12, or negative 12. and add to get negative 1. You see those right there. The difference here is I have an inequality. With a quadratic inequality, we have to test points. Okay? Look up top. Can you tell me, what does it mean to be greater than 0?
It's positive.
That's exactly right. It's positive. I need to know when this equation is positive. So here's the steps you're going to take. When you factor it apart, it's going to give you critical values. So we're going to put those on a number line, right? So x is 4 and x is negative 3. Put those things down on a number line. What that does is it gives you 3 sections. Numbers bigger than 4, numbers in between the two numbers you have, and numbers less than negative 3. Just as a side note, what would this graph look like? Anybody want to guess? What would this graph look like? What happens at 4 and negative 3? So here's 4, and here is negative 3. Does this parabola open upwards or downwards? Up. Why? So effectively, I mean, this is a very rough graph. Effectively, it's going to look like this, right? Right? So if I look at the graph, what's above 0? You mean this part?
Yeah.
And this part? Guess what my solution to this equation is? X is greater than 4 and less than negative 3. Graphically, that's what happens. Shh, listen. If I'm going to do this algebraically, maybe you're very algebra focused. I need to pick a point somewhere over here. I need to pick a point in between the numbers and a number down there. So maybe we use 5. Maybe we use 0 and negative 4. I'm going to take those 3 numbers. I'm going to plug into my equation up top, into this equation, and I want to know which ones make it positive. Take 0, for example. When you plug 0 into this equation, what does it give you? Negative 12 is greater than 0. True or false? False. Jordan. That's kind of weird. Okay? What happens when we plug 5 in? 5 squared is 25. Minus 5. That's 20. Minus 12. It's still positive, right? True. Whatever positive number that ends up being is greater than 0. Which means my solution to this problem would be x is greater than 4 and x would be less than negative 3. Now you don't, in my opinion, what happens in my head is I see the graph. It's not accurate. I know where it goes through the x-axis, and I know if it's up or down. A parabola has one shape. It's either going to be like that or it's upside down. Greater than 0 means it's above the y-axis. Less than 0 means it's below the axis. Or you can do your test points. When we do our test points, we figured out that this was positive, this was negative, this was positive, or this was true, false, and true. The true parts are the answers. The false parts are not. Does that make sense?
Yeah.
So if we shaded, it'd shade here. Depends on where you're looking at it. Depends on how I ask for the answer. Questions?
Do you want us to put it in that final form with the backslash?
You can. I didn't ask for it there, but you could.
Are we gonna do like line stuff now, or is this just we're not gonna ever learn it again?
Line stuff meaning like
Like this stuff? Are we gonna be doing this in pre-calc?
a little bit.
But not too.
Not. Is that hard for you? What confuses you?
This to determine this. I don't understand that. I don't care how it changed.
When you solve the critical points, you can't trust what it says. That's when we have to pick a number in those sections and plug it back into the original problem, find if it's true or false. What you solve when you do it equal, you find out where it's equal to 0. So in fact, it's not less than or greater than yet. You have to figure that out by picking up some numbers and plugging them in to see, is this really true here or is it false here? The true answers are the ones you're looking for. It's not so bad. Shh. Please don't do that 3 times. Okay? I need you to practice it, but not that much. Multiples of 3. 3, 6, 9, 12, and so forth. Okay? The first page is the equations, solving. The second page is the inequalities. Tomorrow, we will talk about a little bit more with the quadratics, and then we'll just kind of review. Monday, quiz. And you're basically looking at what the quiz is over. We're going to talk about word problems a little bit with quadratics. And that'll be, yeah, you know.
So if we can do the homework, then done the quiz.
If you can do all the homework that we've been working on this week, yeah, the quiz was fine. The quiz is over everything we did this week.
It's just like, I know it all, but it's all runs together.
And some of it can. You're just solving basically you're just solving equations. If it's a line or a quadratic, or if it's an inequality or absolute value.
But they each have like little things to do.
So the question is, if I threw a bunch at you at once, would you think hard about it, or would you just do it? That's the question. Turn to the chapter review, chapter P review, and pick a couple of problems that look like what we've done. It'll tell you what sections you're from. And just see if you can do it. Then it puts it all together. Okay. Reminder. Listen, please. If you haven't logged, a lot of you last night, I got emails from a lot of you. A lot of you came in this morning with questions. Couldn't figure it out. We finally hopefully got you set up. If you haven't got this figured out, come see me. Email me the easiest way. Get on your email and just say, I don't know where to log in. And I'll send it to you. Okay? Any questions? Please take some time. Spend on this. This is the hardest thing we've done yet. Okay? This will be on the quiz on Monday. No doubt. Questions so far? I promise you, we'll get to some harder stuff. I know I'm boring you. But we'll get to some harder things real soon.
I won't put it in the class.
Negative.
I got mega buzz with There he is. Where? Come here.
Once they like get started on something, they're like obsessive about it.
What?
Once they start on something, they won't.
These guys behind you?
Yeah.
Oh, they won't be sitting together very long.
There was one like
They're
So
way
like,
too
if they
talkative.
didn't, like, can you
Yeah, but the
not
second
tell me
question
when I got on that?
I put the red card and the red card. Oh, she gave me one that had like the red card and the red card.
Well, she does give out the trick
And I looked at like the opportunity cost because like the red card was the second option.
Oh yeah, it's trade out.
Now I have to go
thought there was
up.
going to be opportunity
Yeah, I
cost.
know.
Yeah, you're supposed to fail it.
I'm not a part of that.
It was so easy though.
Me and Connor are a part of it. It's like 2 people. Well, it's like 3. It's probably 4. It's like Quadratic Formula.
It was actually warmer today.
It's so cold in this school. I don't know why they keep it so cold. Like, better not.
Yeah, I like it cold.
I'd rather it be
Be sweating.
Yeah, I know, right?
I'd rather have it at like 75.
No. I'd rather have it when you gotta keep with a jacket on.
That's what we keep it at my house.
No, our house is not cold.
We keep it at 75.
We're at 70, 77, 78, 76.
Okay, that's a little too hot.
No, I have to be like freezing cold. I have a
Are you
fan on.